Hi, I'm Becca, and I designed a sun clock that is for people like my mother who are not able to see the sun every day. She works in a middle school and always complains that she has an interior classroom, which means she has no windows in her classroom, so she never knows whether it's sunny or dark outside. So I made this sun clock, and it takes the input of a photoresistor sensor and then displays whether it's sunny or not, and also lights up a string of LEDs. So here are the electronic aspects that make this whole process work. So the most important part is this voltage divider right here, where I have a 1 kilo ohm resistor and a photoresistor, and this output that is yellow right here goes to the analog input of a NOT, and that is read by the Arduino. And then based on that input, it outputs this orange wire to this string of LEDs, telling the LEDs how bright to be. And that is a pulse width modulated output. And then here I've coded up my own pulse width modulation to output 11, which controls this servo on the back of this clock here. I'm going to demo my circuit. It's kind of cloudy, so the photoresistor right there is outputting medium sunny. It's not quite cloudy, but there isn't a whole lot of sun. And my output in processing is depicting the same thing, and the lights are off. Processing code output. So I have a flashlight here, and when I turn it on, the output is much higher. As I go further away, it gets darker, and then if I were to cover it with my finger, it gets extra dark. So here is the Arduino code that lets this all be possible, and a large portion of this is just reading the inputs from that voltage divider I described, and then entering these if statements. So first off, I have this if statement that makes sure that the output is different than it was before. And then if it is above 4 volts, it will output a high. If it is in between 2.5 and 4 volts, it will display a gradient. So it will be dark if it's lower and bright if it's higher. And then if it is less than 2.5 volts, it will display a low. In addition to that, I also have this code right here, which creates time constant that controls pulse width modulation of the servo motor. And that allows for the servo motor to display the physical clock of whether it's sunny or not. Processing code that allows this all to be possible. I am loading this sun image, which I drew on a tablet earlier, and then it imports the height and the width, and it also imports all that serial code that we had from the Arduino. So this is null. If it's a null full of zeros, it won't import it. So if it does not equal the null, so it doesn't equal 0, then we enter this loop, and it's reading the string, splitting the token, so splitting the string up, and reading each of the inputs into separate arrays, and those arrays are here. And then it is here I had to add this to convert. So since I'm using a circular clock, I had to convert into polar coordinates here, and then I had to add half of the width of the image because the way processing works, it starts from one side, but I don't want it to start from one side. I want it to start from the middle, so that's what I had to do here. And then it's just redisplaying the background to erase the old line that I created with the stroke, and then redrawing the stroke here. And what that looks like is this right here. Now that I've explained how I did everything, I'm going to leave you with a time lapse of it just doing its thing.